in this next example, we are going to use trial and error to do one of the examples from Coulson and Richardson, where we are sizing a pump, where we are required to specify the power requirements of a pump. The example that we'll be looking at is example 5.2, where we have a tanker carrying toluene that needs to be unloaded. The pipeline is diameter given, the internal diameter given is 225 millimeter. The line length is 900 meter, with miscellaneous losses, the dynamic losses being 600 equivalent pipe diameters. The elevation is 30 meter, and then we know that the ship is at 1.05 bar. The storage tank is at 1.1 bar. We are required to offload 1,000 tons within 5 hours, which means that we have to do about 200 tons per hour. The physical properties of toluene are given, and the pump efficiency is given as 70%. Okay, let's flip to Chemcad to start with the solution for the example. Okay, we will continue with the from left to right approach. We'll start by first saving our simulation model. We will save it example 5.2 for this one. Once we have saved that, we can select the engineering units. We will select common SI, and then what we need to change is just the thickness, in case we need to mention the thickness, and then the pipe diameter in case we need we know we have to specify the pipe diameter for the pipe. Okay, then we have to select our components. We know that we will be handling toluene, which is the first one to pop up. We agree with that, and then we will just for this type of calculation, we'll just accept the recommended models. We will take the ideal model for vapor pressure, and then also use the latent heat for enthalpy calculations. Okay. Then the next thing that we need to do is to draw a flow sheet. We know for the flow sheet we need the feed, we need the pump, okay, and then we need the pipe. Then we need to dispose of our material to conclude the material balance, and then we will just use the stream connector to convey materials from one unit operation to another. Sorry, I haven't selected that. Okay. Okay. You can spend some time to align your flow sheet to make it neat and tidy. Okay, now what we need to do is to specify the inlet stream, which is now the conditions at the tanker. We are going to specify the flow, which we know that is 1,000 tons in 5 hours, which means that we will have to do 200 tons per hour. Let us just do something different here. We're going to specify the weight fraction just to show a different way of specifying this, because it's toluene, is pure toluene, and then the total flow we know is 200 tons, which is 200,000 kilograms per hour. The temperature is not given, so we'll just take a normal temperature of 20 degrees Celsius. The pressure of the tanker is maintained by a nitrogen, is kept under a nitrogen blanket, so it's kept at 1.05 bar. And then let's do the flash calculations for that. We'll agree with that. The next thing to do is let us specify the pipe. The pipe diameter is given as 225. The length is 900 meters. We know we have an elevation of 30 meters. The roughness factor, we know from Coulson and Richardson by just looking at the calculations that they have used, 0.046, but that 0.046 is in meters. So to change it to to millimeters, you can hit F6, and then you know is the value is 0.046 in millimeters. Then you can press enter, and then this will return to Chemcad and enter the value for you in meters. Another thing that you can do is you can exit from here and then go and change the units in your format, engineering units, and change the units for roughness vector to be in millimeters, so that you don't have to keep going around like we have just done. Okay, the specifications, diameter, okay, everything seems to be fine here. We're gonna leave the friction model, vector model as Jane. The properties of the fluid flow, we got it as that, and then the density we'll have to change that. We know we have been given 874, so we're going to change from what's calculated by Chemcad. And then the viscosity, we are also going to change it. We have been given 0.00062. Okay, and then now let's look at the length. I've already entered the length here. We know that we are given that the miscellaneous losses are given by 600 equivalent diameters. So this is that we just put count one of those, then we can agree on that. And then now let's look at the pump. The pump, we are doing trial and error calculations here. So the first thing that we will do is we will enter the pump as let's say the pressure, the outer pressure here, which is pressure of stream 2, we want it to be 5 bar, and then the efficiency is given as 70. I'm just going to enter 70 here, but I know it's a wrong value to enter. So if I click enter, Chemcad tells us this is invalid efficiency. The reason for that is because if efficiency has to be in a fraction, which is 0.7, then we can agree on that. Our specification be complete by now. Let's just look again. Okay, and then let's just okay, then we can run the entire model. You can run one unit up and then run the next one. Choose to run it all because it's a simple model, and it is likely to run without any errors. Okay, let's look at the pressure in the outlet stream is 1.64, which means that we have just over specified by a factor of about 0.5. So if we reduce the pressure here to 4.5, then we agree, and then we can run the simulation. The pressure in the outlet turns out to be just around 1.1, which is what the target is to be at. You probably would have to keep changing a couple of times if to get to the target value of 1.1. We got to that, then we can come to here. We see that we have our head calculated, we have the power calculated, which is in megajoule per hour. Coulson and Richardson gives the power in kilowatts, so we can just hit F6 here to see our units conversion, and then it tells us that in kilowatts it is 31.5, which corresponds with the Coulson and Richardson value of 31. Okay, now we have done a trial and error calculations for pump sizing, basically, or pump energy calculations. What we will now need to do is we will have to do a much more educated way, if you want to call it, instead of trial and error, where you specify the pressure on the at the end side of the tank, and then Chemcad will calculate the energy required to achieve that.